So, hello and welcome to today's episode of DIHUR Podkast. My name is Isabell Furkert, and today our guest will be Taja Kuzman Pungeršek. She is a computational linguist and researcher at the Josef Stefan Institute in Ljubljana, where we also met and worked together while I had my internship here this summer. Taja holds a master's degree in translation and is currently pursuing her PhD at the Josef Stefan International Postgraduate School. She's specialized in natural language processing and machine learning, building language models, creating systems for text classification, and improving tools that help us work with many different languages. She is also the co-leader of the CLASSLA Knowledge Center, which we will talk about in a second. And she's part of the International LLMs for SSH Knowledge Center, where researchers explore the role of large language models in the humanities and social sciences. I'm very excited to talk with her today. Hello, Taja.
Hi, Isabel. I'm very happy that you invited me to this podcast, and I'm also very excited to be talking with you.
So, you basically work at the intersection of linguistics and technology. For those who might not know much about computational linguistics, how would you describe what you do and what drew you into this field?
You already really nicely described the computational linguistics by this intersection between languages and computer science. So a very simple description would be that we analyze language with methods from computer science, so machine learning, data analysis, and a very interesting thing here is that we can really take millions of texts or millions of words and other speech phenomena and other phenomena that we usually analyze in language studies, and we can apply various algorithms over them or some specific data analysis methods to really find some interesting patterns or rules across millions of instances. So what really drew me into this field, I first started as a translation studies student, and there I was always also interested, in addition to languages, interested in computer science and programming. And at that point, when I was finishing my master's degree, this was really start of the rise of really good machine translation systems for also Slovenian. So for my master's thesis, I analyzed machine translation in literature. And then from that onward, I more and more was interested in the machine learning part and in computer science part of computational linguistics. And that led me to the Josef Stefan Institute, where I'm very happy to be working on all of these topics that you mentioned.
Yeah, it's really interesting to see all these computer science skills that you gained throughout the last couple of years, especially coming from a more humanities background or linguistics background.
Yeah.
And one of the places where you're using your skills now is the CLASSLA Knowledge Center. Could you tell us a bit what CLASSLA is exactly and what kind of tasks you and your colleagues are working on there?
Yeah, so CLASSLA is the Knowledge Center for South Slavic Languages, and it is a part of the Slovenian DARIAH-SI language research infrastructure. And as in broader context, the DARIAH-SI and CLASSLA are part of the DARIAH-ERIC research infrastructure, and all of these are focused on language technologies and language resources, and providing and sharing knowledge on these resources. So this is also one of the main focuses of the CLASSLA Knowledge Center, but we focus on the language resources and technologies for South Slavic languages. So we provide information, documentation about how to use these resources, how to find them, and then we also organize workshops on how to use these very big text collections for linguists and language teachers, digital humanists. And also we develop a lot of resources by ourselves, either text collections, speech collections, various models for language analysis, because there is a big gap for South Slavic languages compared to English, for instance, and wherever possible we like to provide resources, not only for instance, for Slovenian, but also for other South Slavic languages.
So one of the language resources that you offer, I know, is the CLASSLA web corpora, which is also the largest general corpus for South Slavic languages, like you just said, Slovene or Croatian, Serbian, Bulgarian, Macedonian. And this CLASSLA web corpora is built on web texts, right? But not just raw texts. You actually provide like annotations, like the data is annotated by genre, I saw, and by topic, and it's completely freely available through online concordances like Sketch Engine. Soon also the second version of the CLASSLA web corpora will be published with texts that were collected from the web in 2024.
Yes.
So it's also quite up to date. Why do you think these kinds of resources are important for linguists, translators, or digital humanists? And do you maybe have a concrete example of how someone might use them in their research, or how they have been used in the past?
I am. So it is very useful, very important for all the researchers that research language and language phenomena to have really large text collections, so that they're really capable of analyzing whether some specific hypothesis they have can be confirmed on large amount of data, not just on a small amount of text that they collected by themselves. And in the past it was really hard to collect such large text collections, because you usually had to do it by hand, maybe digitize the text or collect it otherwise. But anyway, it was a really, really big dedication, and that is also why these web corpora are now the largest for South Slavic languages, because with the emergence of tools that allow us to collect text from the web automatically, this really makes it really easy and efficient to just collect the text from the web by searching for them on all web domains that end for instance with .si, then we search for Slovenian texts. And in such way we managed to, with the same methodology, with the same tools, to collect not only Slovenian text collection, but also Croatian, Serbian, Montenegrin, and so on. And now this has been shown to be really useful for various fields, also for building large language models, because they need to see millions of texts in, for instance, Slovenian language in order to be really good in Slovenian. Then also for training data for other machine learning tools, and especially also for linguists and digital humanists. For them, we also organized a workshop, CLASSLA Express, to train them how to use this corpora. And CLARINESSI has a really nice interface, as you mentioned, the no sketch engine concordancer, where you can just search through the web corpora just by typing the words or phrases that you're interested in, and you get millions or tens of thousands hits with these words. So you can, for instance, this is really interesting for linguists that are searching for some phrases. For instance, they can find some new, for instance, they can analyze proverbs or some metaphors, and really analyze in what context they occur, or maybe how playful people are with language. So maybe whether some proverbs are always fixed or they people come up with some new variants. Then you can also analyze how language changes over time, which is really interesting. So we also have at CLASSLA a corpus named Trendy, which is a news text corpus that gets updated every month or so. And then you can do really interesting analysis how these word usage changed over time, which words or terms are used more in specific period, and also how the meaning changed. So, for instance, during the COVID times, we had new words connected with the pandemic, and a lot of words also changed meaning or gained a new one. And this is really easy to analyze through this web corpora and also news corpora that are available. So, for instance, such research is interesting. So for linguists to look at words and how they change, also find new words that aren't described in the dictionaries yet, because usually it was much harder to think of what are all possible words that Slovenian speakers, for instance, could say. But now you can just check in the actual texts that are written by everyday speakers what are some additional meanings. So this, but also a lot of other uses can be detected here. Also for translators, or content creators, it's really nice when you're missing what could be a great collocation or how something is usually translated. You can also check in these text collections that are sometimes parallel, so you can find actual translations there. And also, just looking for various trends, for instance, which topics occur more and more, or in what type of language in terms of genres is present the most on the web. So really, it can this corpora provide linguists, language teachers, and translators, also other digital humanists, with a lot of possibilities for research.
It's a really powerful tool you created there, and it's great that even languages like South Slavic languages like Macedonian, Montenegrin, who maybe don't have that many resources, get the chance to be presented, and researchers get the chance to get to do meaningful research on these languages too.
Yeah, thank you.
And you just mentioned the workshops, which are a great opportunity for people who are interested to to get some hands-on experience for the CLASSLA corpora. How would you sign up for a workshop like that? Is it on the website, or do you have to be a researcher, or is it for anyone?
So the CLASSLA Express workshops are, we prepare, this is our second year iteration of the workshops, and per year there are around 5 workshops. And you can check out the CLASSLA Express website on the DARIAH-SI website. There's all the information. It's usually 5 or 6 workshops per year, and they are in all different cities. So we are proud that the workshop already visited 10 countries, I think, and 11 cities in South Slavic countries and also Austria. Currently I think there will be some workshops in Graz in the autumn and in Bled. Others have already been done, but we surely will organize more, because there's a very big interest. The last one in Ljubljana was last September as part of the conference of Slovenian Conference for Language Technologies and Digital Humanities, DIHUR. And there you can, of course, also participate as a student. We welcome anyone that is interested, and it also, the workshop doesn't assume that you would have any prior knowledge of how to use concordancers, so it's really beginner friendly. Check out the website and also follow us, CLASSLA, on LinkedIn, where we always post when the next workshops will happen.
Nice. This is a really great way, I think, for people who are interested to really learn how to use the resources, because it's the worst thing when you have built such great and multilingual and annotated resources, and then in the end no one knows about them or no one knows how to use them. So I support that very much.
Yes, it is a lot of additional work to organize such a workshop and prepare all the teaching materials. But we were very lucky that we found collaborators that were interested to do it. We have a really nice team of lecturers that are prepared to present the workshops and travel around, which is, of course, a lot of additional time and dedication. We're really happy that this workshop came to life with such a great team.
Nice. Another interesting set of resources I would like to talk to you about is the Parliamentary Speech Corpora, Parliament, and also its extensions, ParlaCap, ParlaSpeech, and ParlaSend. And these projects take us into a bit of different but equally interesting type of data, I think, and that is parliamentary debates. And Taja, I know that you played a big role in the development, especially of ParlaCap. Could you give us a quick overview of what Parliament is and how you contributed to the ParlaCap project?
Yes, thank you. Parliament is a corpus collection of parliamentary speeches that was developed during Clarn Eric funded project. So these were two very big international projects with partners all across Europe, funded by the European Clarin research infrastructure. And as part of this project, we collected speeches from parliamentary sessions from 29 parliaments all across Europe, mostly national parliaments, but also some regional ones, such as the Basque Parliament. All of the parliament corpora were collected by native speakers from these countries, by our project partners, but then they were all formatted in the same format and annotated with the same tools. So at the end, we created this really big resource with more than 1.2 billion words and 8 million speeches that spans 29 countries, 29 languages, and also all of the speeches were machine translated to English, which allows searching through all of them via the same language. So it's a really interesting, really rich resource. And from that we created the ParlaCap datasets. We are currently working on them as part of the Oscars funded ParlaCap project. And there, these parliament datasets are there additionally enriched with even more information. So the parliament corpora already contain a lot of metadata on speakers. For each speech, you know who said it, so which parliamentary member, then you get some information about this member, what is the gender, the year of birth, also what is from which party this person is, what is the party inclination, and so on. But now with the ParlaCap, we even further enriched the dataset with information on the sentiment of speeches. So this means whether the speaker has a positive or negative opinion, we could say, about what they're talking about. And then also with the topics. So this is from a CAP schema, that is an international schema for parliamentary agendas. And these are a selection of topics that we automatically annotated across all 8 million speeches. And this really provides us with a great resource for various analysis, also linguistic, but especially for political scientists. And the corpora are, of course, freely available on the DARIAH-SI repository, as well as on the concordancer, so people can search through them via searching for words or phrases. While in the ParlaCap project, we also extended this to allow more technical people to use this corpora via tabular formats, so they can do a data analysis even more in a more simple manner.
And I know that Parliament and ParlaCap are quite recent projects, but can you tell us some practical ways that these resources have been used in the context of research or teaching?
Already these parliamentary debates are really interesting, as I said, also for language studies. For instance, all this language analysis that I mentioned before could also be done on parliamentary language, but they're especially interesting, of course, for social scientists who want to analyze, for instance, how the sentiment on a certain topic changed across time. We already have seen some very interesting analysis of what, for instance, based on topics or keywords, what are the most frequently discussed topics in different parliaments, how this changed over time. One can also analyze specific words that relate to radicalization or polarization of parliaments, of the society in general. So it's a really, really great tool or resource for analyzing any hypothesis that political scientists have about how people in parliament speak or what is spoken about on a very big data.
Yeah, this reminds me of the time when I did my internship here. I also worked with Parliament and used the extensions like the ParlaCap and ParlaCent. And one thing I saw there was, for example, I chose the health category, and I wanted to know how the sentiment changed for the parliamentary debates about health across all parliaments, and you could also across time, because you have also the time annotated. And it was really interesting because as soon as COVID hit, the health debates became much more negative. And I also found some outliers, like extreme values, where they were, for example, extremely positive, like in the UK in July 2021, they had the official Freedom Day of COVID, where most of the population was vaccinated and they lifted a lot of the regulations. And for me, it was really interesting to see this, like, these real events and how they are projected in the data and see them in the data.
That's really interesting. I remembered also, now that you were speaking, another really interesting study that was done recently on the parliament data. This was done as part of the, I think, Helsinki hackathon. And you can also analyze this data in terms of, from the focus of gender studies. So at that study, what they looked at is the relationship between parliamentary members in terms of how many women are in the parliament versus how much the women actually speak. So it was really interesting to see that while there might be some parliaments where the percentage of women that are in the parliament is high, this might not necessarily mean that they are represented well in the parliament, as in some cases it was shown that despite that most of women are not represented well in actual speeches, so mostly men then just speak. So such analyses are really interesting. And then a similar thing was done also looking at interaction of parliamentary members on where they looked at who speaks about whom. So the relationship between the parliamentary members, so who speaks about whom and who then reacts, where there were also really clear networks that arose from that, seeing really that some individuals speak much more than others, and also very frequently in relation to some other parliamentary members. So really a lot of really interesting findings can be found and are still waiting to be found from this.
Yeah, maybe we will inspire someone who's listening right now. Maybe a student who needs a project idea.
Yes.
And
I'll be happy.
Yeah. I would also like to talk a bit more about ParlaCap, the topic categorizer that you already mentioned, because for me it's such an amazing task that you created a model or developed a model that can categorize 8 million speeches into 20 something different policy topics. Could you take us through that process a little bit of how you developed it and how you I was also interested in, is it like a perfect categorizer, or is there always like an error quote, and how do you decide that this error quote is low enough to be done now? Can you even be done? Yeah,
thank you. Very interesting question. So, okay, to start, how do one create such a classifier? So, in general, creating text classifiers for various tasks is quite similar. So the main pipeline, we could say, is that you first have to have a lot of text instances that are labeled with the categories that you want the model to learn. So in my case, in the case of the ParlaCap classifier, these specific topics, and these topics are, for instance, they are named like agriculture, internal politics, health, economy, and so on. So such broad topics. And then you also, of course, have to have a good understanding what these topics mean before you try creating the classifier, because you have to understand what you want to achieve, what you want the classifier to learn. So you also have to define the topics well, which will also be important when you will evaluate the model. So you have to first get this annotated training data, and this is usually in terms of thousands, more than, for instance, even 10,000 instances. Usually it could be 1,000 instances, could be enough in some cases, but usually it's even more. And then you, when you have this nice collection of instances, you use machine learning methodologies and architectures to train such a model to be able to basically, based on what it saw in the training data, to generalize its findings to new instances, so that when you will put in the model some sentence about something else that was not in the training data, based on some similarities with what it was in the training data, the model will be capable to find out, okay, this topic is health, for instance. This is the main principle of training text classifiers, also in general, any machine learning models. But here, and maybe to first answer your question about the accuracy, these models are, I would say, never 100% accurate. It would have to be a really, really easy task for the model to be able to really know the task so well that it is for sure 100% accurate. If this would be rule-based, so that you would put some concrete rules, for instance, like if there is a no in the sentence, then this is negative sentiment or something, then this could be 100% accurate, just following the rules. But here we use deep neural networks that are so computationally costly and also complex that it's impossible really to know what exactly is happening, how exactly the model comes to the decision. And it's also impossible to assure that the model would be 100% correct. We never see such numbers. Never, accuracy is never 100. Even 90 is high, very high, and we are usually very happy if it's 70. So if it's 70% accurate, this, especially if there's 20 labels, this is already a success. And this also, of course, depends on the task. So in our cases, such as this topic classification, or I also worked a lot with genre classification, this 70% is a big success, or like good enough for us, because interestingly also this is such a hard problem for humans to agree on that they don't agree on more. So if you put two humans together to evaluate the same number of test instances, the same instances, they wouldn't agree on more than 70%. So if you would take annotations of one human and evaluate them by using another annotator, you would say, okay, human accuracy here is 70%. Mostly because these are not clear categories where it would be just black or white, but it could be a speech where somebody would mention health, like COVID, but also talk about how now, due to that, the economy got worse, and due to that, also due to COVID, the schools are suffering because they have to close, or for instance. And then what to decide? You have to put one category to that speech, not three. In our case, we wanted to have just single label for each speech. So it's a hard task for humans and for models. And sometimes now we've seen trends that even that we used large language models on this task, which was also the case for creating the training materials for ParlaCap. And we've seen that the agreement between one annotator and language models and between two human annotators it was even worse between human annotators. So at that point, you have to know that this is a really hard task and that 100 accuracy cannot be achieved because just even humans don't agree on the task, on the topics itself. But for our case, if you achieve, for our case, we look at what's the best trade-off of how much work we put into, how much computational costs are derived in that process, as well as what is the performance. And at a certain point, you have to say, okay, this is good enough for us. But at any point, you should be always aware that it's good to check some instances and be really aware of what are the so where are the blind spots of the model where it might be wrong. And if I can say a bit more about the training of ParlaCap model, that was quite a fun project, and also it was something new. So we used a new methodology for creating training data that we with my mentor and co-worker Dr. Nikola Ljubesic coined as LLM teacher-student framework. And there, so basically we have, as we said, 8 million speeches and in 29 languages. And if we want the model to work well across 20 categories, it would be good that we would have at least 100 or 1,000 instances per language per category. And this is a really huge training data set that we would have to, if we would want to do it as we did it always in the past, we would have to annotate it manually. So we would have to find 29 native speakers, and then we have to train these speakers to understand the task well enough to actually agree on the same labels. And then, of course, you have to lead the campaign. So all of this is takes a lot of time, a lot of money, and then even at the end, manual annotation with so many different annotators can be at the end questionable, as they might not agree well. So that means that they have different views on the labels, and the model can get confused trying to make sense of that. And here, with the occurrence of large language models, we've seen that for tasks such as topics, they are quite powerful and actually can understand what health, for instance, means. And basically what we experimented on, and it was shown to be very successful, is that we used the LLM to automatically label this training data. So we just provided the LLM with the short description for each label, what it is, and ran it across all of the I think it was like 30,000 or something like that instances. And then we, of course, also manually annotated test data to check how well this LLM performs. And as I mentioned, it was shown that it performs as well as human annotators. So it's based on its agreement with other humans, if we compare it with the agreement between the humans, is the same whether we use that model or humans. So for this specific task, we actually created this training data by annotation with an LLM. But an LLM is too computationally costly, and it would take too much time and also too much money to actually use it across these 8 million speeches. So what we then did is that we trained smaller language models that we could run on our infrastructure, on our highly powerful computers, and then we use that model to annotate all of the corpora. And so in that way, we were able to use powerful LLM to get training data and then do what we usually do. So train a smaller model.
Yeah, so you always have to keep the computational resources and everything in mind, which is something that me as a linguist, I was really used to think about, RAM and everything. But in the end, it seems very efficient to work with LLMs in that way.
Yeah.
And so, for instance, if you have a training set and you have 70% accuracy, so I don't know, maybe out of 100,000 instances, 70,000 were categorized correctly. What do you do with the other 30% with the other 30,000 instances then?
So we with these smaller language models, which are named fine-tuned bird-like models, these models have a very good advantage that when they have to classify a text, they don't output only the label, but they output its, we could say, confidence. So score from 0 to 1, for instance, it can be transformed in such way. So confidence for each label, what's the probability that the text is of that label. And based on that, you can actually get out we could say, prediction confidence of the model, how certain it is that the text is classified correctly. And we, in such cases where we apply these models across such huge datasets to annotate them with additional information, we use this information, the confidence values, to filter out the instances that are not classified with a high enough confidence. So in these cases, if the confidence is low enough, we don't provide the label that the model may be guessed on, but we say that we provide another label that we name mix. So the mix label then is a solution to maybe a clearer data set, so that we avoid having too many wrong predictions. And that is one of the solutions how we make the corpus clearer.
Very interesting. And so now we basically learned what Parliament is and what ParlaCap is and what it can be used for. And I have one last question about this topic for you. Why do you think these kinds of corpora are so useful for linguistic studies or political research or digital humanists?
Yeah, thank you. This is, I think ParlaCap and Parliament corpora can provide really a totally new set of possibilities for especially social scientists and digital humanists, because before it was never possible to be able to look at, for instance, all parliamentary speeches from 2015 to 2022, or even for longer periods of times, so easily. So usually you had to dig through some archives, some websites, and just read each speech separately and then try to find some meaning from all of that. But of course, it's impossible for a human to read everything and then find such patterns across such big numbers of speeches, and especially across languages. So as we now have machine translated texts in English, this can really help also to look at patterns across languages that you otherwise wouldn't be able to look at because you don't probably speak 29 languages. So this is a really great resource for the political scientists, for digital humanists, to be able to find phenomena that they are interested in, and find some, maybe check their hypothesis, research questions on a really large number of instances. And this is also very interesting for phenomena that are rare. So, for instance, if you're looking some specific, I read a paper of somebody who was looking for statements when one politician accused another of producing false information. But if you would just go read through the speeches, just open the website and start somewhere, it would be almost impossible, very unlikely that you would find anything. But now, with all of these speeches in one place, possibility to search through keywords, through words, different phenomena, different word word types and so on, you can actually just search through them and find these instances that otherwise would be just buried in all other speeches on all other websites. So yeah, it's a really great tool, and I think it will make researchers' life much easier than the very lengthy search through the archives.
Yeah, it's a really meaningful resource that you created with various use cases, a lot of which still have to be explored and hopefully will be explored. And I'm really excited to see what people will come up with.
Yeah, me too.
And finally, if someone is listening now who is interested in doing research with Parliament and ParlaCap, what would you say is a good way to get started?
Yeah, definitely. I would say the first thing, of course, is to get familiar with the Parliament and ParlaCap data that are available on the DARIAH-SI repository and on the concordancers. So for the linguists that would like to search through the data with a very simple tool, we have the concordancers at the DARIAH-SI infrastructure, which is everything is freely available, and you can just find the Parliament corpus or any other corpus that you're interested in, even its translation to English, and type in words or phrases or some specific choose specific topics that you're interested in, and this provides you with the first insight: what is in the corpora, what are parliamentary members speaking about. And then for the also in that case it's useful to attend any of the CLASSLA Express workshops to learn how to use the concordancers for searching through the corpora. But for people who are more interested to use the data sets via, for instance, Python code, so via programming tools and data analysis methods, I would really recommend tutorials that were created by our Isabell here during her internship. And these tutorials really provide a really nice introduction, even for people, I would say, that haven't coded before. I think it's so nicely explained that it's a really great introduction to Python, to Pandas library, and to using code for data analysis in general. So it provides provides codes and explanations how to open the data set, how to analyze all of the data sets, look at sentiment, topics, create really nice graphs, even timelines, how some topics or sentiments change across time. So it's a really good first tool to delve into the data and then start from there.
Nice. Thank you very much. This was very interesting. And not only I learned a lot, but I hope our listeners learned a lot about this very important project as well. Do you have any last words?
Yeah, I would thank you to inviting me to this podcast. It was really nice, and I'm happy that I had the opportunity to spread the word about all the things that we do, about CLASSLA, CLASSLA Express, DARIAH-SI resources, Parliament, ParlaCap, and I really hope that these resources will be taken up by the digital humanists, by social scientists, and that they will enjoy them as we do.
Thank you. And thank you very much for listening. And we will hear each other next time at DIHUR Podcast.
Thank you.